Now we pass on to a more complicated topic, which is actually compound interest. And this is where we'll have to use our calculator in the end of year exams. So we'll write it here so we remember what we're doing. Just quickly position this. Yep. Okay. We'll put this here and we'll put compound interest. All right, so this is the topic we're dealing with now. Good. So this is in chapter 10, and it's also, when you think about it, a pretty simple topic. So compound interest, this means that the investment actually, or the interest rate actually adapts to the new value. So it compounds. It's pretty simple concept. And so how do you do this? So the actual formula is VF equals VFV equals PV1 plus R over 100 times N. However, the problem is we're in math applications and we're not trying to do this, right? We want to use our Ti84 to be faster, to be more efficient. So how do we do this on the calculator? So I'll teach you guys how to do this with a simple example. So let's take, okay, we'll put this calculator here. And let's imagine question 1 in your exam, which asked, so question 1 is going to help us distinguish and realize the difference between simple interest, what we just did, and compound interest. So we see that there's an actual difference. And this is what this question will actually show us. So let's say Messi invests $2,000 at a simple interest of 3% per year. All right. On the other hand, Cristiano invests or deposits the same amount of money, 2,000, right, at a compound interest of 2.9, so even less per year. However, over time, this will go and will become larger than the value of the other person. So let's prove this. So for Messi, we'll buy here. We'll do this here. And for Cristiano, we'll do this here. So let's show, right, how much money both persons will have after 10 years. So what we do is we take 3% of 2,000, which is evidently 60, and we multiply this 60 times 10 for 10 years. We'll just write it here, which equals to 600. So after 10 years, interpret 10 years, Messi will have $2,600 in the bank, right? So at the simple interest of 3%, his money has grown of 600 in 10 years, right? Now we take the case of Cristiano, who's invested at a compound rate of 2.9% per year, and we actually realize that he actually gains more money despite his interest rate being lower, and this is because it's compounded. So what we do is we could either use the formula, so but we don't want to use the formula. So this is where the calculator actually comes in. So for the calculator, it's very simple. You want to take the calculator, right? Yes. And you want to go to apps. So I'll actually create a new thing. So GdC, step 1, go to apps, and you want to select finance app, right? So you want to, as you see here, select finance app, enter, and go to the first option, TVM solver, right? So I'll write it here, select TVM solver. Okay, so once you're here, right? Let's put this all to 0. All right. Once you're here, you see all these numbers or letters, and I'll quickly write these down while I tell you guys what they are. So if you want to, you can take a screenshot. Here, so you see N, you see I and the percentage symbol, PV, PMT, FV, PY, CY. So this is simple, right? So N, however, you want to remember what these means, is the number of payments. So just like before, of payments. I, this is interest rate, so evidently. PV is the present value. So here it's extremely important for PV that in present value you mark it with a negative sign in front, right? So let's say if a person invests or deposits 3,000, right? Here in PV you'll write negative 3,000 always, right? You always want to put a negative sign on PV because it kind of like he's to just write negative. Then for FV is the future value, and then PMT, just leave it on 0. And then PM, it's periods, sorry, PY. PY is periods per year. And yeah, so PY is periods per year. And finally, CY is compounded or compounds per year. So let's get this straight. If it's compounded annually, so annually, you would write on CY equals 1. If it's monthly, you would write CY equals 12. Okay, simple. All right, so let's come back to our example. So what do? We go here and we write N. So for N, it's a number of payments. So we said 10 years. So we write 10 there. The interest, we said it was 2.9. The PV, this is the initial value. We write again negative, you see, negative 2,000, important. PMT we leave on 0. FV, we don't write anything because we don't know the value yet. And then CY, as it's annually, we leave on 1. Then alpha, enter, and it gives us the answer. After 10 years, Cristiano Ronaldo, we can write it here. We'll have, as you can see here on FV, 2,661. So after 10 years, $2,661.8. So this means he has 61 over Messi. right? Simple. Now let's take another example. Let's load another page. All right, and let's take, for example, let's say you got a question, it's question 2, right? Question 2 on your test. So let's write this here. Question 2, right? And you want to do this. So question 2, like we did before on part 1, is how long does it take to double money, in this case in a compounded interest scenario, right? So this is what we're doing now, and yeah, this is also pretty simple. So what you want to do is actually right, yeah, so let's take this example. It says person Y invests or deposits 80,000 euros this time into a bank at so compounded annually at 3%. Yeah, and actually quarterly. And what does quarterly mean? Quarterly means once every so quarterly means once every quarter, so 4. And yeah, it's pretty simple. So we go with part A. Asks calculate how much money Alexis has, so person Y has in the bank after 6 years. So let's say U6, and again we return to the calculator, and I would recommend you guys to follow and rather than just look what I do, look at what I'm doing. So 80,000 and compounded quarterly. Okay, so simple. So we go here, and so N 6 years, I is 3, PV is negative 80,000, remember the negative, and then this we can leave on 0, and CY now we change and we put 4. So we go alpha solve, and we see that after 6 years the value has increased by almost 16,000 and is now worth 95,713.1, let's say, euros. So that's what he's got after 6 years. Now we go to question B, which asks how long will it take for the money to double? Take for money to double. So this is simple. You want to go back on your calculator. However, this time what you're going to do is you're going to kind of replace, because what we don't know in the calculator is the value of n. So we can mark n as a question mark right here. We want the final value FV to be 160,000, as this is twice 80,000, right? So this is pretty simple. So we return on here and we write here 0. We leave this as it is, and on FV we're now going to actually include something because we know what the final value is. So 160,000, and now we go to n. I write it here, n second solve, and the answer for n is again in blue. So sorry, alpha solve, my bad, alpha solve. So we go alpha solve 23.2 years, 23.2 years, which in essence means, yeah, after 23 years. So yeah, after 23.2 years, person wise money will have doubled. So as you guys can see, this is actually pretty simple. And yeah, there's not much to it. It's learn how to use your calculators. You guys can go back in the video. I'm not gonna ask for you guys to like, to subscribe or anything, because it really doesn't matter. And yeah, so I don't know if you guys may see this better like this. Sorry for my terrible camera quality, but it is what it is. And yes, good luck. That's what I'm gonna say. Good luck. And adios.